Hello everyone, my name is Akiran. I'm an exchange student, and today I would like to present the solution for the homework 2 set number 2 and explain some key concepts that we used in these sets. The first one is the logistic regression. So logistic regression is the approach that we use to deal with qualitative response variables like color, gender, and disease. So it models the probability of some object belonging to some category. So, for example, we want to identify the category of fruit. So what fruit? We have apple or orange. So the logistic regression will model the probability, for example, that a fruit is an apple is 70%, and the probability that fruit is an orange is 30%. So this is, and the range of probability will always be from 0 to 1. So, and in percentage from 0% to 100%. So in logistic regression we use logistic regression model use logistic function. So why do we use logistic function? Because it gives us outputs between 0 and 1. If we use linear regression, it will not give that precise range from 0 to 1. It may give the output between 0 and 1, but it also may give the outputs below 0 or above 1. So, and that's why we use the logistic regression or logistic function. And logistic function has the S-shaped curve. Now the concept is the odds. So the quantity px divided by 1 minus px is called odds. So it shows us the relationship between the probability that event will happen and the probability that event will not happen. So it gives the value between 0 and infinity. And the last moment in the odds concept is the log odds or logit, is the logarithm of relationship of the ratio px and 1 minus px. Yeah. So, and the last concept is the multinomial logistic regression model. So the basic logistic regression model can deal only with two categories, with two classes. So in my previous example, when we wanted to identify whether a fruit is an apple or orange, there are only two categories of fruit, orange and apple. But what if we have 3 categories or 4 categories? Like what if we have orange, apple, and also we'll have pineapple and banana. So in this case we need to use the multinomial logistic regression model. So there are several ways to so there are two ways of to multinomial logistic regression model coding. So one of them is softmax coding. So in numerator, so for example, if you want to calculate the probability that our fruit is an apple, in numerator we will write the value for the for the for our category, and in denominator we'll write the the total sum of all categories, of all four categories: apple, fruit, orange, apple, orange, pineapple, and banana. So this is multinomial logistic regression model using softmax coding. So let's go with the solution explanation. In the A problem, we need to find the log odds of orange versus apple. So what do we need to do? So the first one is to find the opposite probability. So the opposite probability is the probability that our fruit is an apple. So we need to subtract from one our probability equation. So when we subtract it, we'll obtain the in numerator 1 and in denominator 1 plus exponent to the power of beta 0 plus beta 1 x. And the final the second step is to find the ratio px divided by 1 minus px. So when we divide px by 1 minus px, we need to simplify our ratio, and we will obtain exponent to the power of beta 0 plus beta 1 x. So once we obtain our relationships, so in other words odds, so we need to take the logarithm on the left hand side and the right hand side, and in the end we'll obtain in the left hand side the logarithm of px divided by 1 minus px, and in the right hand side we'll obtain beta 0 plus beta 1 x, because there was the exponent to the power of beta 0 plus beta 1 x, so it was reduced once we took the logarithm on the right hand side and the left hand side. So this is the log odds of in our model. So basically in the set 2 we have two models. So in the problem A, this is our model, and in the B, in the problem in the B problem, we have our friend's model, and we also need to find the log odds of orange versus apple. So Friend's model used the softmax coding for the multinomial regression model. So we, as I said earlier, we use multinomial regression model for category if we have more than 2 categories, but we also can use it with the case when we have only 2 categories. In our case, it's orange and apple, so it's 2 categories. So, and let's find the log odds of orange versus apple. So, in the previous exam, in the previous problem, we subtracted from 1 the probability of orange, but if we use the softmax coding, we don't need to do that, because in numerator we write the exponent to the power of say coefficients for the apple, and in the denominator we write the total sum of all probabilities. So to find the probability of apple, we write in numerator the probability that our